Now, grading this problem is going to be a little bit tough because it's not using, or the person writing the answer is not using our certain methodology in terms of structuring the answer in an easy way for the AP grader to get it graded. So hold on, we're going to get through it. So looking at this question, they give you some background information about filling milk containers. And there's some really important information in there that I hope that you did read. But it gives you sort of like what should be happening. That the milk containers contain at least 128 ounces of milk, and that they also, another important piece is that they are normally distributed in terms of the actual contents of the milk. And the other thing, we have 12 containers that we have somehow been randomly sampled from all the containers that are filled up. So let's take a look at part A. It says the sample mean and standard deviation of this sample, and they give you that information. And then the next part of the question, is there sufficient evidence to conclude? Now, as soon as I see that, I know it's a test. So I look and see what I've been given to decide what kind of test that I'm going to have. I have one sample of 12. All right, and what do I know about that sample? I have a mean and standard deviation. So that means I know I'm going to be working with a one sample t-test. And you'll notice the person answering that question actually wrote that down immediately, I guess to remind themselves as to where they are heading in this particular question. So when you start a test of any type, you're going to start out with the hypothesis part, the ho and the ha. Now this person, okay, we're going to see, some differences here in terms of the way I've taught you how to do these problems. We're going to start out with the ho. Now we can see here the first check is going to be mu equals 128. That is the null hypothesis, but I do not see any words that will identify the true population mean amount of milk being equal to 128 ounces. So that means the word part is missing, so they are not going to get the second check for the null hypothesis. Now, it should be that the null hypothesis states that the true population mean amount of milk in a container is 128 ounces. That's the null, that's the ho. Now the ha, well, let's see. What are we trying to find? That it's not in compliance. Well, not being in compliance is not saying anything about what direction, over or under. It's just that it's not 128. So the ha is going to be that mu is not equal to 128. It's going to be a two-tailed test. So a check mark if you have the right ha, that it's not equal to 128. But guess what? They don't have the words again. They're not going to get that second check for the ha. That should be is the alternative hypothesis states that the true population mean amount of milk in a container is not equal to 128 ounces. So the hypothesis part is worth 4 points. My person got 2 out of the 4. Now the next thing I'm looking for is conditions. Now generally I would have you write out the conditions using the word conditions, and we're going to have 1, 2, 3, 4, and then we're going to have a since statement. Now this person, it's a little bit harder to grade because it's not quite as organized as I have you do the problems, but let's take a look at number 1. All right, number 1 is independence. You would say that the milk containers are independent of each other. Now my person does it right up here, check, so that will be the first check for independence. Number 2 is randomization. Did you say that the problem states that the containers were selected randomly? Because they were, it says in the problem. My person says it right here. It's not perfect. I would say that the containers were selected as a random sample as stated in the problem. I'm going to go ahead and give credit for that, all right, because I have the word containers right next to it, so I have some context going on. I prefer you to write a sentence for each one. This person gets credit, it's just not as organized as I would like. Number 3, we have the 10% condition. And what I would like you to say is that n equals 12 containers is less than 10% of all milk containers. If you said that, give yourself a check. Now this person did it in a roundabout way. They said that 10 times 12 containers, which is 120, is less than the population of all milk containers. The AP will give credit for that. It's not the way that I've taught you how to do the problem, but it means the same thing. So number 4 is the nearly normal condition. And the nearly normal condition, the sample size is equal to 12, which is less than 30, and that makes me very, very, very sad. So in this particular problem, I know that I am trying to find a way to box plot the information to check the sample distribution. There is no data here. So the next thing I'm looking for, did they give you a box plot or a histogram or a dot plot or a 7-leaf plot that we can look at to check for unimodality, approximate symmetry, and outliers? Hopefully there are none. And you notice that's missing too. So that means there's an obligation in the text to tell you about what the sample's distribution looks like. So if you go back to the problem, it does tell you, okay, I sort of broached that subject at the beginning. It says, variability in the filling process causes the actual contents of milk containers to be normally distributed. So in this case, we know the parent population is normal. So that means I know that the samples are also going to be normal. So what I'm looking for here is in the nearly normal condition, since the sample distribution from a normal parent population is normally distributed as stated in the problem, and then we get to the good stuff, then you can say that the sampling distribution of mean amounts of milk in the containers is nearly normal. So that is not there for this problem. My person does not get the nearly normal condition. All right, they have nearly everything. They have 1, 2, and 3, but they do not have the nearly normal condition. And then the next thing I'm looking for is, since all conditions are met, we're going to do a 1 sample t test. Now my person, oh, it's not as pretty as the way I know you've done it, but they did identify the process, the test, by name right up here, so they are going to get that check mark. So for the conditions part, there are 1, 2, 3, 4, 5 checks that you can get here. Independence, randomization, 10%, nearly normal, and then the since statement. My person only gets 4 out of the 5. So conditions. All right. So now the mechanics, you can do a direct copy off of your calculator to be able to write this one out. So I'm going to go ahead and put mechanics right here. You'll notice it makes it so much easier if you organize your work for the AP reader the way that you've been taught. It just makes it so much simpler. So what I'm looking for here, do you have the T statistic? Check. All right. Write it down directly off the calculator. You do not have to calculate it. This person did a direct copy right down here. Did you use the word p-value? My person did not, but they do have the right p-value, 0.0935, so they do get a check for that. So far, we have 3 checks for the mechanics. Now, we also are going to identify what the degrees of freedom, and that is 11. Remember, on a 1 sample t, it's going to be equal to n minus 1, and my person has it correct. All right, so that means there are 1, 2, 3, 4 checks right here that we're looking for. My person has, let's see, 3 out of the 4, and now we're going to continue to the conclusion. All right. So let's take a look at that. The first sentence in your conclusion should be restating the test, all right? And then they're going to use a mathematical comparison. You're going to compare your p-value against the alpha level. So I know this is hard, all right? So looking at this is due to the p-value. They've stated their p-value, okay? They've stated their alpha level, yay. But guess what? They did not compare it using a mathematical comparison word. And they also did not restate the test that they used for this particular problem. So no point for that. So your first sentence should be using a one sample t-test, check. My p-value of 0.0935, check, is greater than, check, my alpha level of 0.05, check. So my person only got 2 out of the 4. So in this case, all right, if the p is low, reject the whole, it's not. So that means you're going to write down, I fail to reject the whole. All right, now my person, guess what? Oh, they accepted the whole, not good. So that means they do not get the point for saying, I fail to reject it. All right? We actually don't know anything about the veracity of this claim at this point. This particular sample just didn't tell us anything about what to do. We just don't have evidence of anything. So that is the next thing that we're going to be saying. We do not have evidence, okay, that it's not equal to 125. So I don't see that sentence here, okay, that they've restated the ha. So I'm going to put an X right there, okay, so that's going to be the third sentence. They say that there is not sufficient evidence, okay, there is no evidence to conclude that the plant is not within regulations. They are restating the question, so they are going to get a check for the fourth sentence. All right, so for the conclusion, we have 1, 2, 3, 4, 5, 6, 7 checks. All right, so out of 7, my person is missing, let's see, 1, 2, 3, 4 of them. My person only gets 3 out of the 7. All right, and that is the end of grading this part A. Now this actually comes from a question number 6 from an old AP test, and there are more parts. This is going to be the investigative task question, but it fits our instruction right now. So 7 plus 4 is 11. 11 and 5 is equal to 16. 16 and 4 is equal to 20. So up at the top, out of 20 points, figure out how many points you got. My person got 3 and 3 is 6, plus 4 is 10, plus 2 is 12. My person got 12 out of 20, okay? So put that on your paper. So eventually you're going to do your whole total, but this is the end of this particular grade.